Welcome back to what is actually a new update video. I was going to be continuing with the tutorial series, but there's been a bit of delay on that while I've been working on features in DAD Builder. I've now reached a stage where I think I'm going to release, or have just released, the latest version. Some of the features are not quite finished, but are well on their way. So what has changed since the last release? We went for a few of the changes in the last video. In the visual editor now, if you import a project that you haven't imported before, it will try and lay the map out from the directions of the rooms. It works quite well for simple adventures, but in adventures where you have up and down locations and everything else, it'll do its best to try and map that out. You obviously will want to rearrange the rooms yourself. So we had a change in the way the mouse works now. The left button, you can drag over a series of rooms and then you can move them complete as a block. Previously that you would scan around the canvas, allow you to move around the canvas. The middle mouse button now is the one to drag the canvas around. So that's a change in the visual editor. As we covered before with the message editor, now you can click on the little plus button here between the message number and the message contents, and you can add a label to describe what that message is about. So it's dark, and that'll then create a message in the defines, and it'll show you here what that label says. And then in the text editor, if you want to add a message, you can now use that label. We'll just make it a bit easier to use messages and to remember what those messages stand for. If you're typing in message 0 every time, you look back at your code in a month's time, you won't really remember what message 0 is. So you can add defines for system messages, as we did just here, and you can also add defines for your user messages. And if you go into the defines, they should appear at the bottom of the list here. So there's the system message define we just added, and you can delete that there as well if you want to get rid of that define later on. So the biggest changes that have been taking place are in the graphics editor, and this is adding vector drawstring graphics. It's a bit of nostalgia for me to have those graphics. As I've said before, the DAD Ready package is absolutely amazing, with the ability to add raster graphics and compress those down, and they load relatively quickly. So I think it's a bit of a shame that vector graphics didn't really survive to the modern versions of DAD. I quite like them. It may only be me that likes them or will ever use this, but it's another feature available for anyone that does want to use it. As it says very clearly in red at the bottom, this is all very experimental code at the moment. The ZX Spectrum, Commodore and the Amstrad versions are pretty much complete and mostly tested and seem to work. MSX is a new one, just started adding. This is very much a work in progress at the moment. There never was an MSX vector drawstring editor. The graphics were always created with the ZX Spectrum, and then there's a program to convert them into MSX drawstrings. There are also programs to convert the Commodore and the Amstrad versions as well. The drawing process pretty much used to be you'd design them in the ZX Spectrum, you'd run one of the conversion programs to copy them over to the Commodore, the Amstrad and the MSX. So if we look at the original Spectrum graphics editor, it was all very key based, but actually really nice programs for the time. So right at the start when you went into the program you had a main menu. Your first one was where you could add graphics, so you could add pictures in, and you could amend those graphics from within there. And you could print out that picture, you could look at how big the picture was in bytes and do various options with that. You then had your character editor, where you could amend the characters in the character set. You could change your font, etc. from there. We already have that with our font editor. You could change the default paper color and ink color for your graphic window for that particular picture. You could change the size of that picture as well. You could rearrange the text colors in DAD as to which numbers you wanted to refer to which colors. You had a feature where you could set the amount of memory you had spare. So at the end of the compilation of your adventure, the compiler would give you an address which was the next address that you could use that was free. By default this comes with 38900. We're just going to put that figure back in to get back out of this window. And if you set that spare, as you created your pictures, you could look at how much free memory you had left while you were progressing. Then you could save your database, reload your database, and on some of the editors you had the ability to select where you're going to save it to, disk or cassette, and you could list what was on the disk. They all were very slightly different, the Commodore and the Amstrad graphic editors, but mostly pretty much the same in common with each other. So if you go to graphics and you go to insert a picture, it'll insert it in the next slot. You then had to use your keyboard to move the cursor across the screen. So the beginning point here was known as the base cursor, and the other end was known as the rubber cursor. The base cursor was where the next drawing function would start from. So if you press Ctrl and L, that would fix a line on the screen. The base cursor has now moved to the end here, so you can hold down Shift to move a bit quicker. So that's our base cursor. Our rubber cursor is here. You could then do things like you could move to an absolute point. That will now move your base cursor to this point here without drawing anything. You could do a very similar thing, which was to plot, and that will plot 1 pixel at that area, and again move the base cursor to that point. You had the options to fill, so if you had a shape you could fill it. You could shade that in, and the shading would use the fonts from the character set. And you could do a block fill, which would, you could select an area on the screen, and the block fill would fill with the paper color, your currently selected paper color. And that was like a really quick way to change a block area of colors, because all it did was change the paper attributes. You didn't have to draw any pixels or anything else. So we look at how that converts to our DAD Builder vector graphics. In DAD Builder we have the same commands that you could use. The Spectrum and the Amstrad versions both start with the 0, 0 point of your XY coordinates here at the bottom left. The Commodore, being different, has it at the top left instead. The MSX coordinates for the machine itself was like the Commodore. It would start at the top position, but the way the conversion worked with the Spectrum and the MSX, it actually puts the XY 0 coordinates at the bottom left, so we mimic the same thing here. So we can use a mouse instead of our cursor keys to draw lines and everything else. So we can click on line and we can just plot our lines on the screen. You'll notice as I'm plotting those lines, there's a series of commands arriving on the right hand side. These are the commands which will match how that is stored in your database. And if you want to go back, in the spectrum you could go back using your cursor keys until you reach the right line, and then you could change where that line began, where that line ended, or how long it was, and those sort of things. Here we can jump straight away to alter any of those, and we can change from the bottom here the XY coordinates for that line. If we change the paper or ink color, it will add a paper or ink command, so we can change to yellow paper, and then we can try the block move. So if we drag that out, it will now fill all of those 8x8 pixel blocks with the paper color. And you say that's a very quick way of coloring an area of the screen. Again, we can change the ink color by doing the same sort of thing, and we can draw our line across there, and that line will use the paper color we've just set and the ink color. We can fill the screen, we can do absolute move, we can do a plot, we can add text on the screen. That will jump for the Spectrum and the Commodore to the nearest 8x8 pixel block and start in the top left corner. For the Amstrad, you can actually plot that text by pixel level accuracy. We have a grid feature you can turn on. You can turn on snapping to the grid to make it slightly easier to draw lines. We'll have to be aware when you're using that it's going to snap to the right of that pixel grid line. So your very last point here will actually be in the next 8x8 pixel block, which will change the attributes for that block. So when drawing a straight line, if you're using snap, you might actually want to just take it back one point to stay within the 8x8 pixel blocks. You're not having color clash running over into the next square. You can set inverse and over for your lines. You can also set the bright and flash attributes. We don't actually mimic flash on here. It will export with flash, but it won't actually show it flashing on the screen. It's a feature we probably will add eventually for the Spectrum, but it's the only machine that actually supports this. So like on the original editors, you can set the start address for your free memory, and it will keep a track of the size of your database and how much free memory you have left. And it will show you the size of each picture here, the amount of bytes your picture takes up. And each command down the side will show you how many bytes that command takes. And the size of your database also includes the size of your character set, because that's exported in the vector graphics database. So whilst building this, had a huge amount of help from outside. So we had help from the source code from ZESAR UX, which has a lovely debug feature in it for adventures, where you can actually look at the graphics in the game. So by being able to look at how they were reading the graphics and deciphering them, we were able to match or check that we were matching what they were seeing. In the early days we were miles away from that. Now we match that one-to-one. For the Spectrum, there was two versions of vector graphics. The later version was a compressed version. So having worked out the graphics for the normal Spectrum version, we tried importing some older ones which came out largely as garbage. Couldn't quite understand why. We had a huge amount of help from Pedro Ferdinand, who very kindly gave us the source code of various utilities he had written for vector graphics, as well as copious notes of his findings of reverse engineering those graphics formats. And they were absolutely invaluable in helping us to work out the compressed format and really improving the way we imported graphics. All the way through, we were very fortunate to have access to the graphics from the original AD adventures, which were released in the original DAD discs, and we were able to import those and see how well they rendered in our system. The button we have here is clear all pictures. If you want to clear your database entirely, you can click clear all pictures. That's quite handy for the feature here, convert to. So from here you can choose to convert to the Amstrad Commodore or MSX formats. You can choose whether, because the Spectrum screen was smaller, whether you want to scale that to try and fit the Amstrad and Commodore screens, which are wider, whether you want to not scale it and stick to the coordinates starting on the left hand side, or whether you want to center that image in the screen. A lot of the AD adventures would center the Spectrum graphic. You can choose whether you want to try and convert the colors. That's a bit hit and miss because the Amstrad works so very differently with pens rather than ink and paper, and the Commodore has a much wider range of colors, and anyone that knows the Spectrum of the Commodore will know that the colors are quite different between them. Again, with the block data, that also may be a little bit hit and miss. The shade and fill usually converts across quite nicely. Bottom we have an import button, so we can try and import databases, and if I just try and import one of those original databases from the AD games, which we were using to test, this was our main go-to from the one of the games, and initially these pictures looked nothing like this when we tried importing them. Over time, as we improved our understanding of the commands and our import process, they now look the same as they do in the games. What was really nice with the vector graphics, in fact that's the only one that doesn't look the same. We have one slight issue with the last command, which if we remove it, looks exactly the way it should do. Haven't quite worked out why that final colouring of this top square affects that graphic, but the rest all look really good as they do in the game. What was really nice with the vector graphics was you had subroutines, so the actual ones that are images here are highlighted in white and the subroutines are grey italics. The pictures are the ones that you'll actually see when you're playing your adventure, and if we click on the little cog button here, we see the metadata for that picture, and here we can choose whether it's a subroutine or a picture. If that is checked, this image will not show up in your game. It'll be treated as a subroutine. And the subroutines, if we can find one, a lot of these were off the screen on the Spectrum ones. Let's go near the end. So the subroutines here, you could embed these in your picture. So all of these little parts meant that you could create very similar looking pictures like these without having to redraw the whole thing over and over again. You can add go subs in, and then you can call a subroutine from that go sub. So we look back at the picture 15 here, you'll see a lot of these pictures are very symmetrical, and what we have here is we have a go sub. The first one here, go sub 0, draws the box around the screen, and then down the side we have go sub 5, and that draws half of this picture. And then the other go sub, when we click on it, you'll see it's mirrored in the x-axis. So you place one go sub on this side mirrored in the x-axis and one on the other side, and then you get the whole picture, but you've only actually really taken up the data to draw half of that picture on. If you delete one of those go subs, you'll see that half of the picture has totally vanished now altogether. So that was like a really nice feature. You could have subroutines for doors or windows, and you could have, say, 4 windows in a picture, but you've only actually used up the data for drawing one of those, and then you've just repeated that across the screen. You could have a door and a picture of an open door, and then to change the picture you literally just call a different go sub for that door being open. So then we have our convert options. So we can try converting this across to the Amstrad, and I will say not convert the color across. We won't scale it, and we will align it to the center. Start converting. One of the other options which I could have had there was on the convert. You can also, when you're converting across, copy the spectrum font across as well, because the shade patterns will use the font to do the shading, so you may want to copy that across as well, obviously being aware that the spectrum is 8x5 font and the Amstrad is 8x8. The Commodore is also 8x8, but slightly wider pixels to allow for the Commodore's scaling. If we go across to the Amstrad, we'll see that first subroutine has come across very nicely, and then if we look at the pictures, we'll see they didn't work very well because of the shading and the fills. This is where the clear all button comes in handy. We can clear all the pictures. Right back to the beginning, we can go back to the spectrum, we can go convert to, and we can choose not to convert the fill and the block and the shading or the color, and this will just take across the line coordinates. And we need to go to the Amstrad target, start conversion, go to the Amstrad, and now we'll see the outlines of those pictures have come across. And we can then choose to colour, fill or shade those later on. If you want to add commands in between the commands we already have here, like the process editor, you can choose the command you want to add in. So we might want to choose a block colour, and then we can choose where we want that to be added, and we can just add that in there. And that will add the block color to the bottom, and then we can adjust that with our coordinates from here. Or again, we can do that from the controls up the top. So if we go back to the spectrum one, just clear all pictures. I'm going to import second part database into there. So there's another series of pictures from the second part of that adventure, and again you can see how similar these pictures are because they're pulling from subroutines. So I'm going to very quickly do is I'm just going to create an adventure with 35 rooms. We can just keep going north through those rooms and see how these vector graphics look in our finished adventure. So give me one moment while I put that together. So I now have a very messy layout of 35 rooms that we can whiz through north to south. So if we export this in the graphics editor, we have our pictures there from the original AD game. Just to note, at the moment we don't use those in Test Adventure. That's a feature which will be added on later on to be able to display either the drawstring graphics or the raster graphics. If we export that as a zip file, we can then extract that into our dad ready folder and then use the files from there. So I'm just going to do that now. So now I've exported that zip file and I've unzipped it into my dad ready folder. There are a few changes from the default Dad Ready install. Now in the images folder you'll have a drawstrings folder, and for each computer that you had drawstring images for, there'll be a target folder here of Spectrum, Amstrad, Commodore and the MSX, and within that will be your graphics folder. I've been doing some testing, so there's some extra graphics here as well. This is the one we've just imported. In the assets folder there will be the old original interpreters, because the newer Dad Ready interpreters don't support vector graphics at all anymore. So we need to use those older interpreters to be able to run games and see those graphics. And then in the main folder there'll be a few more bat files. So here we have a ZX48 tape drawstring bat file, and if I run that, it will now compile a adventure with the original interpreter and those drawstring graphics in there as well. So just give me a second. So here is our compiled adventure. We have a lot of locations running north into each other. So if we just start going north from location 1, there's our first graphic. And our next one. And so on through those graphics. So that is where we are at so far with the vector graphics editor. It's at a stage now where we can draw graphics, we can export those, we can create a running adventure with those, we can import older original graphics as well. We can convert those between the different platforms. We can pretty much cover all of the features that the original drawstring editors had, plus the extra features of the conversion programs as well. So still working on the MSX version, and there will be more changes. The ability to be able to view those within our own test adventure as well is to come in the future. But that's it for the moment, and that's it for this video. I'll see you in the next one.